Number 22, a heavy 2-kilogram point-like object rests 2 meters from the center of a round turntable as the turntable rotates. The period of the turntable is 5 seconds, so they gave us the period. The coefficient of kinetic friction between the object and turntable is 0.5. The coefficient of static friction, a little higher, 0.8. What's the magnitude of the force of friction acting on the subject, on the object? All right, so let's draw a free body diagram. So here's the point-like object. We know its weight is directed down, its normal force is directed up, and we have a frictional force, a static frictional force, pointed toward the center in the same direction of the acceleration as long as it's rotating, right? It is rotating. So what we do know is that the maximum static frictional force that we could have on this would be static frictional force would have to be less than or equal to mu s times Fn. So the maximum static frictional force would be mu s, which is 0.8, times mg, which is 2 times 10, and the maximum static frictional force would be 16 newtons. All right, so now at least we know what the maximum static frictional force could be. We may or may not be at that static friction, at that maximum value. We could be less than that. So let's sum up the forces. We have the summation of forces equals mv squared over r, and it's static frictional force equals mv squared over r. But we don't know what the velocity is, but we were given the period, and we know velocity equals 2 pi r over period. So that would be 2 times pi times a radius of 2 over a period of 5 seconds. And that gives us a velocity of 2.5 meters per second. So we can plug this in and have a 2 times 2.5 quantity squared divided by a radius. The radius is 2. So the static frictional force would be 6.3 newtons, which is less than a maximum.